In this lecture, we're going to look at object IDs in MongoDB. So you have noticed that when you store a document in MongoDB, MongoDB sets the value of the ID property to a long string like this. So here we have 24 characters, and every 2 characters represent a byte. So essentially we have 12 bytes to uniquely identify a document in MongoDB. Now, out of these 12 bytes, the first 4 bytes represent a timestamp, and that is the time this document was created. Later, I'm going to show you how to extract this timestamp from this object ID. So with these 4 bytes, you don't have to create a separate property in your document like created at, because the timestamp is included in the object ID. By the same token, if you want to sort your documents based on their creation time, you can simply sort them by their ID property. So the first 4 bytes represent a timestamp. The next 3 bytes represent a machine identifier. So 2 different machines will have 2 different identifiers. The next 2 bytes represent a process identifier. So if we generate 2 object IDs on the same machine but in different processes, these 2 bytes will be different. And finally, the last 3 bytes represent a counter. If we are on the same machine, in the same process, at the same second, but generate 2 different documents, the counter bytes will be different. So with these 12 bytes, we can uniquely identify a document in MongoDB. Having said that, there is a very, very, very low chance that we will generate 2 object IDs that are the same. Let me show you how that can happen. So, you know that in 1 byte, we have 8 bits. In each bit, we have either a 0 or 1. So how many numbers can we represent in 1 byte or 8 bits? Well, that is 2 power of 8, which is 256. So with 1 byte, we can store 256 different numbers. Now, I told you that the last 3 bytes represent a counter. This is like the counter that you have probably seen in SQL Server, MySQL, and other databases. So an auto-incrementing number like 1, 2, 3, 4, and so on. So how many numbers can we store in 3 bytes? That is 2 power of 24, which is 24 bits, or 3 bytes. That is 16 million. So if at the same second, on the same machine, in the same process, we generate more than 16 million documents, this counter will overflow. And that's where we may end up with 2 documents with the same object ID. But you can see that this is a very unlikely scenario for most applications out there. All I want you to know is that this object ID is almost unique, but not 100%. Now you might be curious why we don't have a mechanism in MongoDB that guarantees uniqueness. For example, in database management systems like SQL Server or MySQL, in each table, we have an auto-incrementing number that guarantees uniqueness. So next time we want to store a course record in our database, the ID of that course will be the ID of the last course plus 1. This approach guarantees the uniqueness of these identifiers, but it hurts scalability. In MongoDB, this ID that we have here is not generated by MongoDB itself. It's actually generated by MongoDB driver. So we have this MongoDB driver that talks to MongoDB. So this ID here is generated by the driver, and that means we don't have to wait for MongoDB to generate a new unique identifier. And that's why applications built on top of MongoDB are highly scalable. We can have several instances of MongoDB, and we don't have to talk to a central place to get a unique identifier. The driver itself can generate an almost unique identifier using these 12 bytes. So when we build an application with Node and Express, we use Mongoose. As I told you before, Mongoose is an abstraction over MongoDB driver. So when we create a new object, a new document, Mongoose talks to MongoDB driver to generate a new ID. Now you can also explicitly generate an ID if you want to. So let me show you. I'm going to clear all this. On the top, let's load Mongoose, require Mongoose. Here we can create a new object ID. So let's set this to new Mongoose dot types dot object ID. And then let's log this on the console. And here in terminal, let's run this program that is node. I created a separate file, objectid.js. So look, we have a unique identifier and we didn't store anything in MongoDB. We generated this object ID in memory. Now I told you that the first 4 bytes represent a timestamp. If you want to get that timestamp, you can simply call get timestamp. So this object ID has a method called get timestamp. Save, back in terminal. Let's run this again. Look, this is the time I generated this object ID. We also have a static method on this object ID class for validating object IDs. So mongoose the types the object ID dot is valid. So I can pass a string here, 1, 2, 3, 4. Obviously, this is not a valid object ID. So when we log this on the console, we should get false. Console.log is valid. Let's run this again. And here's the result. So now that you understand object IDs in more detail, in the next lecture, we're going to get back to our Vidly application and make a few changes to make our application better.